Hi everyone. Today we're going to be talking about one of the most basic yet the most vital topic in math. So this topic is none other than numbers. We use numbers, practically everywhere in our daily lives. When you wake up, you look at the time. It could be on a clock or a digital alarm clock or anything, but that includes numbers. When you go to breakfast, you might be drinking milk or you could have cereal. So you could be drinking one glass of water or two strawberries, something like that. Three pancakes, something like that. So, and when you go to school, you put on your socks, you put on two socks. So all of these daily life activities all include numbers. If you think about it, numbers are everywhere. So that is why we are going to be talking about numbers. Now, numbers may seem pretty basic, but they do have a lot of subparts and topics that we are going to be talking about today. So, before we dive into the topic of numbers, let's talk about a number line. So to do that, I'm going to draw a number line right here. Oh, yikes. Okay, that seems pretty even. I'm going to drag this down a bit. It's slightly off, but that's okay. So now what we're going to do, we're going to add arrows right here. The reason we're adding arrows is to show that numbers are endless. Now, if you think about this, it actually makes sense because whenever you think about a large number or the largest number you can think of, you can always add 1 to that number and you would still get a bigger number. So there really is no end to numbers. So that's why we are adding these arrows to show that numbers are endless. So let's mark the middle over here. I'd say it's right here. Oh, that's off. Yeah, okay. So over here, we're going to write 1, 2, 3, 4, 5, 6, 7, 8. And it really just goes on until the number infinity. Now, as I told you before, numbers are endless, and we call this infinite. So we show that by this symbol over here, which is the symbol of infinity. So all these numbers over here, 1, 2, 3, 4, 5, 6, all the way to infinity, are natural numbers. So they're called natural numbers. Now, you may have noticed that I didn't include the number 0 here. That's because 0 isn't a natural number. So all the numbers from 0, 1, and then 1, 2, 3, all the way to infinity, all of these numbers are whole numbers. So all the numbers from 0 to infinity are whole numbers. Now, you may have noticed that all the space over here I left empty. Well, that we aren't going to keep that empty. We are going to be adding something over here. So to show you what we're going to write there, let's talk about the concept of negative numbers. So negative numbers are numbers that are anything basically less than 0. So all of these are less than 0. So how can there be numbers that are smaller than 0? Well, to introduce this concept, let's talk about earning and spending money. Let's say you went to work and worked for about 3 hours and you got paid $40. So that means $40 was added to your bank account. Then you went home and you decided to get yourself a treat. So, and you spent $50. So that means you spent more than what you have. So this can be done by using a credit card or something like that, but that means you are in debt. That means you have to pay $10, which you haven't paid yet because you've spent more than you have. So you can think about this as in debt too. If you were paying a mortgage and you took a loan, then you are in debt to that loan, meaning you owe money. So that is what negative integers are. So negative integers are shown by using a minus sign in front of them. That means there's going to be this -1, -2, -3, -4, -5, -6, -7, and then it goes up all the way to negative infinity. Now, all of these numbers, negative numbers and whole numbers and natural numbers together make integers. So that may seem like a lot of numbers, but we're not done yet. So have you ever thought about the concept of there being numbers in between numbers? Well, that is possible. Whenever you pay for, let's say, a candy bar, and it costs you $1.50. Well, that costs $1.5. So we could write down 1.5, 2.5. There are many other numbers in between numbers too, right? In between 2.5 and 3, there could be 2.75. Oh, that is hard to write. I'm just going to rewrite 3 then. So, and then 3.5, 4.5, 5.5. Oh, this is going to take a while to write. 7.5, and then it goes on. -6.5. So, yes, there are numbers in between numbers, which we call decimals or fractions, in negative integers too. That means there can be decimals in negative numbers too. So that would work too. I'm just currently trying to finish this. Okay. So all of these numbers, oh, I really need to move this. So over here, all of these numbers including the decimals, are called rationals. So that is a lot of numbers. So to understand this more, did you notice how whole numbers are made up of natural numbers, while integers are made up of whole numbers and natural numbers, and rationals are made up of integers, whole numbers, and natural numbers? So to show this, we can draw a Venn diagram. A Venn diagram is basically when you're using circles to represent a graph or a chart. So to do that, I'm going to do my best to draw a Venn diagram. Over here, let's start off with natural numbers. Actually, I'm going to use a different color for this. Oh. So I think that big is good enough. So over here, this is our natural numbers. Now our next one, ooh, yikes. I should probably move this into the middle of this. Now these are our whole numbers. Now our next circle, I am going to move this. Okay, and these are our, oh yikes, that is not centered. And now these ones are our integers. And our last circle, oh, this is going to be big. Are our rationals. So that is our Venn diagram. Oh, I should move this. So, we've talked, oh, yikes. So now we've talked about natural numbers, which are natural numbers are numbers from 1 to 2, 1, 2, 3, 4, all the way to infinity. Then we have our whole numbers, and these are our numbers 0 and all our natural numbers. So whole numbers are basically all natural numbers plus 0. Then we have our integers, which are negative numbers, and are all of our whole numbers. So that is a lot of numbers. And lastly, our rationals, which are our numbers which have include decimals. So that is all of our types of numbers. Okay, so now we've talked about those numbers, let's talk about a different type of number, which are called irrational numbers. So, irrational numbers are numbers that are never ending, meaning they never end. So, at first thought, you might think that these are numbers which are extremely large, which are so large that they never end. Numbers like the one I'm about to write. So this is not never ending, because at some point or the other, it has to end. Irrational numbers are numbers that never end, but are a decimal. So you may have noticed that this part in irrational is rational numbers. So numbers that are rational. Yeah, that would make sense for them to be decimals. So numbers that are irrational are numbers that never end but have decimals. That means they are numbers like this one, except they are after a decimal, so it could be 7 point whatever this is. So a few examples of irrational numbers are, well, one very famous example would be pi. So this is pi. If you haven't heard of pi before, well, that's okay. It's just a really famous number, which is an irrational number, and is used when you're trying to find the circumference, which is a perimeter of a circle, or other things when you're talking about circles or angles. So pi, I can write down a few digits of pi, which is 3.141592654. So this goes on, and it never ends. So this is an example of an irrational number. Another one is, well, another number which is an irrational number is 22 by 7. Now this is also kind of like pi, except it starts with the first 3 digits, but it isn't exactly pi. So 3.142857143 143. Okay. So another one would be the root of 2. So roots are shown like this, square root, and they are used to find a number that when multiplied by itself gives this number. So if I wanted to find what the square root of 4 is, I'd say 2, because 2 times 2 is equals to 4. So that's the same thing as 2 squared. So the square root of 2 is another irrational number, which is 1.4142135562. So that is another example of a irrational number, and there are a lot of square root there are a lot of numbers when you try to find the square root of produces an irrational number. So you can try experimenting that by yourself. So basically irrational numbers, I wouldn't say are rational numbers. They are different because they never end, while rational numbers do end. Okay, so now let's just summarize that one more time so that all of that information isn't really hard to process. So we've learned about 5 types of numbers. They are, numbers. They are natural numbers, which are numbers 1 to infinity. Then we've talked about whole numbers, which are numbers 0 to infinity. Then we've talked about integers, which are numbers negative infinity to infinity. Oh, and all of these are not including in decimals. And then we've learnt about whole number. Then we've learnt about rational numbers, which are numbers negative infinity to positive infinity with decimals. And lastly, irrational numbers, are numbers from from negative infinity to positive infinity with never ending decimals. So thanks for watching this video. I hope it helped, and be sure to like and subscribe. Bye.